This problem is all about the calculations for friction and Newton's laws. A 50-kilogram crate rests on the bed of a truck. The coefficients of friction between the surfaces are, we have the kinetic coefficient of friction, UK, is equal to zero point 0.3, and mu s, this is the static friction coefficient for as zero point 0.4. Find the frictional force on the crate when the truck is accelerating forward relative to the ground at, for letter A, we have 2 meters per second squared, and for letter B, 5 meters per second squared. Now, as you can see here, if we're going to draw the free body diagram of the truck carries a 50-kilogram weight with the motion of acceleration going to this direction. And then if we're going to consider our crate here, our crate now has the following forces. Okay, this is the FBD for the crates. We have the weight of the crates, which is 490 newtons. So we get this value if we multiply 50 kilograms with 9.8 meters per second squared, and the normal force is the counteracting force of the surface, which is also opposite with the weight of this crate. Now, I repeat, the normal force is usually the opposite force of the weight. Now, our friction could be either in this direction or this one if the truck stops or goes. Okay. So for letter A, application of Newton's second law to the crate using the reference frame attached to the ground yields as the following. Summation of the forces with the horizontal axis or x-axis is equal to the mass of the crate times the acceleration of the crate. So since we're going to solve for the frictional forces here, the first one we're going to consider is the frictional force, static force. When we say static force, this is the force at which the friction exerted on the body is relative to the acceleration as equal to 0. Now, if we're going to balance the left side of equation as the f of x, or force of x, with the horizontal axis or x-axis, this only gives us frictional static force, Fs. Fs stands for static force or static friction, is equal to mass times acceleration, ax. Now this gives us 50 kilograms times 2 meters per second squared. Our static force here gives us 100 newtons, or in scientific notation, this is 1 times 10 raised to 2 newtons. Now, for the second one, we're going to use the summation of forces with the vertical axis as f of y is equal to mass times acceleration y, ay. Now, this is the balance of the following. We have the summation of forces for the y-axis as positive normal force and negative weight. This is positive because it points upwards, and our weight is negative because it points downwards. Now, this is n minus 4.9 times 10 raised to 2 newtons is equal to 50 kilograms times 0. Okay? Our acceleration here is 0 because the crate doesn't move vertically. Okay? It moves only horizontally. It doesn't move vertically. Now, if we're going to further simplify this, n gives us equal to positive 490 newtons, right? The maximum value of the force of static friction gives us the following. Fs now is equal to mu s multiplied with the normal force. Now, this is the formula for static friction. This is the coefficient of static friction multiplied with the normal force. Now, substituting the following values gives us 0 0.4 multiplied with our normal force, 490 newtons, or in scientific notation, this is 4.9 times 10 raised to 2 newtons. Okay, this gives us with the answer of 196 newtons. Now, for letter B, F is equal to mass times acceleration. Okay, this is horizontal acceleration. For letter B, this is given as 5 meters per second squared. So 50 kilograms times 5 meters per second squared, or this is in 250 newtons. Now, since this exceeds the maximum of 196 newtons, the crate must slip. So it will slip. The frictional force is therefore kinetic. Okay? We're going to use the kinetic coefficient of friction, which is zero point 0.3. Now, our kinetic force is equal to the kinetic coefficient of friction, mu k, times the normal force n. This gives us our mu k, or kinetic of friction coefficient, zero point 0.3 times the normal force at 4.9 times 10 raised to 2 newtons, or this is 490 newtons. Now, our final answer for letter B is 147.